Hi everyone, welcome to the tutorial on velocity time graphs. So in this lesson, we will be looking at how to interpret velocity time graphs. Okay, so here is the knowledge organizer for a velocity time graph. And there are two key things that you need to notice on the velocity time graph. The first thing is that it is the velocity which is represented on the y-axis, which is a speed, and there is time which is represented on x-axis. So it's basically looking at speed, how the speed changes over time, not the distance, but the speed. And the area under the curve gives us the distance, and the gradient at a particular point will give us the acceleration at that point. So when you get a question on finding the distance travelled on a velocity time graph, it's the area that you need to find under the curve. Now the keywords are velocity, speed, distance, area, trapezium. Now the trapezium here, so if you were to find the area under the graph or under the curve, so we end up dividing it into trapeziums and finding the area of those and adding them together, and that will give us the distance. Okay, question number 1, it says, below is a sketch of a speed time graph for a cyclist moving on a straight road for 7 seconds. And it says, work out the acceleration for the first 3 seconds. And part B is the calculate the total distance covered by the cyclist. So 2 things you have been asked to complete for this question. Okay, now the acceleration is the gradient of the graph, and gradient is like change in y divided by change in x. Okay, so if you look at the graph in the first 3 seconds, so the change in x is 3 and change in y is from 2 to 5. So the change in speed is 3 meters per second. So if you work out the gradient, 3 divided by 3 equals 1. So the acceleration in the first 3 seconds is 1 meters per centimeter squared. Okay, now it says, the second part, it says, calculate the distance covered by the cyclist. So we know that the distance is the area under the graph or under the curve, if the graph is a curve. Okay, so distance covered by the cyclist. Now, if we look at the area, just going to get rid of this. So the area under the graph here, so we got one rectangle from 3 to 7 seconds. So this is 4. And then from here to this point is 5. So the area over here is 24 times by 5. Now the area on the first part, in the first 3 seconds, well, I'm just going to take this as trapezium. So we got A, B, and we got height of trapezium. So the area formula for trapezium, so the area is half A plus B and then times by the height. Now if you substitute the values in, so half, A is, if you notice here from 0 to 2 is 2, and the other side B is 5. So 2 plus 5, and the height is, remember the perpendicular height of the trapezium, so there's a 90 degrees angle over here, and that is 3. Okay, so times by 3. So if you work this out, so 7 times by 3 is 21, and half of 21 is 10.5. So if we add these two values together, we got 20 plus 10.5, that is 31.5, which is the area of the both shapes added together. So that is the total distance covered by the cyclist on this graph. Okay, question number 2 says a sprinter runs a race of 200 meters. So they have already given us the distance for this question, which is 200 meters. And remember, the distance is the area under the graph or area under the curve. And we're given a graph here, and the first part of that graph is a triangle, and then we have a rectangle here. And it says work out the maximum speed of the sprinter during the race. Now the maximum speed would be at this point over here. So basically working out the height of the rectangle or the height of the triangle. Now the second question is, it says calculate the distance covered by the sprinter in the first 5 seconds. So distance covered, that means we need to find the area of this triangle, and that will give us the distance covered in the first 5 seconds. Okay, so let's go for the speed one first. Now we know that the height over here is same because it's a rectangle and 2 lengths are the same. Now the length of this rectangle is 20.32 take away 5, which is 15.32. So the area of the rectangle and the area of the triangle makes up the distance, the total distance covered in this question. So the area of the rectangle would be 15.32 times by the height, and then add to the area of the triangle. Now the area of the triangle is half times by base. Well, the base is going to be 5 and times by the height. Okay, and that all equals 200. Okay, so if we simplify this, we have 15.32h plus, now half of 5 is 2.5, and we got 2.5h equals 200. Now if we add these two values together, okay, so this comes to 17.82h equals 200, and h equals, we divide both sides by 17.82, and the answer is 11.2 to 1 decimal place. Okay, so the maximum height of this sprinter, or the maximum speed, is 11.2. Okay, now the next part of the question says calculate the distance covered by the sprinter in the first 5 seconds. Okay, so the first 5 seconds we have to find the area of this triangle. The height is 11.2, so let's work out the area of this triangle. Half times by 5, because the base is 5, and times by 11.2, okay, which is 28. And the units for that would be meters. Now, if you use the full decimal value on your calculator, your answer might be slightly different to this, but it's around about 28 meters. Okay, so that is the full working out of this question. Okay, question 3 says, here's a speed time graph for a train journey between 2 stations. The train travelled 2 kilometers in t seconds. Okay, so we don't know this time over here. And it says work out the value of t. Okay, so we're given this key information that 2 kilometers is the total distance which was travelled between these 2 stations. And the speed on the side is meters per second. So 2 kilometers equals 2,000 meters. Okay, now remember the distance is the area under the graph here. Now if you look at this graph, it's in the shape of trapezium. Okay, so we have A and we have B. Okay, and we haven't got the height of this trapezium. Well, sorry, we're given the height, which is 20. We got 20 on this side here. Okay, now the formula for the trapezium is area equals half A plus B and times by the height. Okay, so the only thing missing, if you can find out what B is, okay, and then we should be able to find this distance from there to there and the value of T. So if you put our information in, so the area is 2,000. That was given in the question. Half. And A and B. So A is between 30 and 90, which is 60. Okay. And B is all the way from there to here. Okay. So I'm just going to call that just B over here. And the height is 20. Okay. So if you simplify this, and times both sides by 2 to get rid of this half. So we got 4,000 equals 60 plus B times by 20. And then 4,000 divided by 20 equals 60 plus B. So basically we're trying to find what B is by rearranging this formula. So 60 plus B equals 200 and B equals 200, take away 60, and B equals 140. So the total distance from there to the point T is 140 altogether. But we know up to this point, okay, so we got 0 to 90 and altogether it is 140. So T equals 140. Okay, so another typical exam question on velocity time graphs or speed time graph. It says here's a speed time graph and use 3 strips of equal width to find the estimate for the area under the graph for the first 3 seconds. Okay, so first 3 seconds only. And then it says, describe what your answer to part A represent. Now we're looking at the area under the graph, and that represents a distance. So we can put this in because that will be the answer for this, distance travelled. Okay, so now looking at part A, it says use 3 strips of equal width to find the area in the first 3 seconds. So first 3 seconds. Now because the graph is a curve and we cannot find the exact area under the curve, and I'm going to split this up into 3 equal strips. Now if we were to split this up, let's just say from there to there, so let's draw this line again. Okay, so from there to there, and from this point over here, and from there to here. Okay, so these are 3 strips that we have to divide the graph into. Now if you look at the strip over here, now if I was to just like draw a line from this point to here, this becomes a trapezium. Okay, so trapezium means, so we got A and B over here, and we got the height of the trapezium at the bottom. And if I split this up into another trapezium here, so again this would be this A on this side of this trapezium and B over here, and then the height again is 1 of this trapezium. And then the last section, I'm going to use a triangle from there to there. Let's make that into a better triangle and work out the area here. Now obviously we're estimating because we cannot find the exact area, because there are some areas here that we have not covered under the graph here. So the answer would be an underestimate, okay, because we're not adding in the area of these little parts over here. Okay, so if I just say this is trapezium 1 and this is trapezium 2, and this is the triangle, which is the area 3. So the first trapezium, so the area equals 1/2 A plus B. So A would be, now if you look across here, again we're estimating, and roughly it is 3.3. So this side is 3.3, and this side here would be 3.9. So that is 3.9 over here. So 3.3 plus 3.9, and then times by 1, because this is the height of this trapezium. So that's one area we need to find. The second area of the other trapezium, which is the one here. Now A, I'm going to take that as 2. Okay, so that would be 1/2, 2 plus, and we already got the height of this side here, which is 3.3. And then the vertical height of trapezium is 1 again. So that's area 2 that you need to work out. And then area 3 is the triangle at the end here. So we got 1 on this side, and we got 2 as the base. So 1/2 times by 1 times by 2. So it's 3 areas that you need to find out and then add the answer together. Okay, so these are the answers for these, and now just add all the answers together. 2.65 and plus 1. Okay, so that is 7.25. Okay, so that is the answer for this question. And the part B was describe what your answer to part A represent, and we already said it's the distance travelled. Okay, it says here is the speed time graph, and work out the estimate for the acceleration at t equals 2, or when time is 2 seconds. And then it says use 5 strips of equal width to find an estimate for the distance travelled in 10 seconds. Okay, now the first part is the acceleration, we said earlier, it equals a gradient. But since it's a curve, now t is 2 seconds over here. Now we have to draw a tangent roughly representing the shape of the curve at that point and find the gradient of that line. We simply can't just do change in y, change in x from this curve here. So, okay, so anything like this, which roughly follows the shape of the curve. Now, if we find the gradient of this line, so again, change in y divided by change in x. So I'm just going to draw out a triangle here and try finding the change in y and change in x. Now, if you look at the x-axis, we got 0 to, let's just say, we got 3 in the middle, and it would be 3.1. Because it's an estimate, 3.1, we can go along with that. And then at the top here, we got 40, and 40 minus 5, that is 35. And then change in y divided by change in x. So 35 divided by 3.1. So that is the gradient. Okay, so 11.29. Now, don't worry if your answer is slightly different to mine here, because it depends on how you're drawn the tangent. And remember, like, different tangents will go at different places. So you might have a slightly different answer to this. Now, in the next part, it says use 5 strips of equal width to find an estimate for the distance travelled in 10 seconds. Okay, so now we need to divide this graph into 5 equal strips. So again, I will draw some lines out, and 5 equal strips, and it's between 0 and 10. So each strip would be worth 2 on the time side. So if you draw these lines out, okay, and the last one here. Now the first one, I'm just going to use that as a triangle. So the height of this triangle, this is 27 on this side, and the vertical, sorry, that's the base, and the vertical height would be a 2 here. So remember, all these distances are equal, so we can put 2 each. Now the other strips here, for example, this one again, trapezium. Okay, so we can find the height, the one length of the trapezium, that is 44. So it's easier to find all the distances first. Okay, so quickly completing this trapezium over here. And the length of this side is 20. Okay, so now again, using the trapezium formula, work out the areas of each of these parts. Now the first one, so the area. Okay, so I've split each of these shapes and worked out the area for each of the trapezium and then the triangle in the end. So if you add all of them together, it comes to 348, and that is the total distance travelled for this question. Okay, so that was the part B. Remember, it's an estimate, so yours could be slightly different if you drawn your lines at a slightly different place. So 348. Okay, so one other typical exam question would be, is this the underestimate or overestimate? Okay, so now if you look at our curve, and we have not included the areas of these little spaces that is between the lines and the curves. So our answer is going to be underestimate on this example. Okay, so the whole question.